Hello everyone, today we will talk about a slope analysis problem as we are seeing the problem here. So let's get started. Our prime concern is to measure the factor of safety from the above problem. So for this we will use a software that is named Rocscience. So I will set my problem here and here is the software we have. So let's create a new project. So this is a new project and let's see our problem. So this is the problem here. You can see that this is a figure of a soil which has three layers: soil 1, soil 2, soil 3, and there are three type of soil in each layer, that is soft clay, medium stiff clay, medium dense sand. And we have the cohesion properties, friction angle, the moist unit weight, saturated unit weight, etc. here. So from this figure we have to just put it in the software and then run the analysis to calculate the factor of safety. So at first what we will do here, we will set the boundaries, we will add some layers, define the soil properties, and then we will just run the analysis. So it is a very simple problem. So let's get started. At first we will go to the project settings from the properties, I guess, or the analysis. So in this analysis tab we have the project settings. Here you can see that I can adjust the units, so I can make the stress unit to imperial, which will be feet per second. And about the failure direction, it's left to right or left to right or right to left. So from the figure you can see that it is actually right to left. So what we will select here is right to left. And then comes the data output. It will be standard, and here we have nothing to do with the soil profile. You can just say that use the soil profile, and then you have nothing to do with the scenarios. About the methods, we will mainly calculate the factor of safety in two methods, which is Morgenstern price and the another one is Spencer. At the end of the tutorial we will talk about the factor of safety calculation methods and why the Spencer method and Morgenstern price method differs. Okay, so for now just choose them. And here is groundwater. We will not do anything here because we are not we don't have any groundwater problem here. And then you can see in the advanced tab it will be just as it is. So we will check OK here. So it will give you a warning that the unit has changed, so it doesn't matter, just remember to save the file. Okay, make it a new name like video project. So I will save it at video project. Then what we will do, we have checked the methods, we have did the groundwater, then we will do the boundaries. Okay, so let's go to the boundaries. So here you can see that we don't have anything. We should have the did we save it right? Yes, so from the project settings, okay, we should not use the soil profile, we will define the soil profile. Okay, so now in the boundaries you should see that there is a tab which is add external boundary. So we will go to this, and according to the figure, let's see, at first you can see that this position is 0 0. Okay, So at first let's take the position 0 0. Okay, so we have got a position, and then the second position that we are indicating is 0 50. Okay, so 0 50 will be in 0 50, so it will 0 0 and this will be 0 50, the upper y direction. Okay, so let's take here 0 50. So now we are here, and then the second one will be, you can see that it is 50, so this position will be 50 50, so we will take 50 50. So let's write here 50 50, and then you can see that we have a position which is just 50 plus 70, this position, so it will be 50 plus 70, 120 in the x direction, and in the y direction this is 50 and this is 35, so it will be 85. So this position will be 120 85. So let's give 120 85 here, 120 85. Okay, then you can see that there is another position which is 50 feet after this 120, so this position will be 170, and the height will be 85 as the previous. So it will write here 170 and 85. Then from the problem you can see that this position will be in x direction, it will be 170 as always, but it will be 0 in the y, so the another position will be 170 comma 0. So here we are. Now I can just add them. So here you can see that I have made the boundary, and for the boundary materials you can go to the boundary tab and you can see that you have the add material option. So you will go to the add material option. Where is it? Okay, or from the properties you can go to the define material option, that will be easier. Okay, so at first we have material 1, you can see that we have the soil 1, and it is named as soft clay here, so you can give it soft clay. This is actually easy software, soft clay, and you can see that the unit weight here given is 110 to 115, so you can keep it 120 as it is here. Okay, and the cohesion is 400 and friction angle is 12, it's given here, so the cohesion is 400 psf, sorry, 400, and the angle will be 12. So check OK. Again go to the define materials option, go to the second one. Here the soil 2 is medium stiff clay, so just choose here medium stiff clay. You have to input it manually actually. Sorry for the keyboard noise. And the unit weight will be as it is, and the strength type will be more coulomb, and the cohesion as we saw it will be 750 and 15, so make it 750, and the phi angle will be 15. Okay, so it will be 15, and now we will define the third layer. So go here and see the problem. Here is the third layer is medium dense sand, so we will write here medium dense sand, Where is it? Okay, I will write medium dense sand, and you can see that it is varies between 130 to 135, so you can make the unit weight 130 here. And the question will be 0 as given in the problem. And what was the angle? The angle was 35, so the angle will be 35 as it is. So you can click OK, then go to the define materials and just delete these. You don't need this, the other two layers. Okay, so you can save this. And now what to do? Now you have to assign these properties. So go to the assign properties. Oh, we have to do another thing. Sorry, I forgot. We have to add some more boundaries actually because of the soil layers. So we can go to add material boundary. We have to add material boundary to give the soil properties, right? So for the material boundary, just see the figure here. The one is at 020 point and the another is 170 and 30 points. So let's check 0 20 and then 170 30. Okay, so it's done. You need another boundary for material, so that will be 0 30. You can see from here that it is in 30 and this point is actually the total 170 and here 65. So one point will be 0 30 and the another will be 170 65. So you can right click and select done. So you are done. Now assign the properties. So here the soft clay, click one time here, then double click here. Okay, then click one time here, then double click here, then click one time here and then double click here. Now you have assigned the properties. Okay, now you can save the file. You can save as the video project. Okay, so we are almost ready to run the model. Actually, we have assigned the properties and we have defined the surface. So for running the model, we have to go to a tab, this tab actually. It will say that slope stability results are not present and blah blah. Don't look at that, just go to yes. So after running the model, you can see that we have got our factor of safety, one from the Spencer method and another from the Morgenstern price. But you can see that there is a difference between these two method calculation, like one is 1.331 and another is 1.333. So there is a difference. And again, if you see the, like if you choose just one slice and you see the forces here, you can see that each of the forces differs in every slide here. And then another thing, in case of Morgenstern price, if you see, you can see that the forces are different in each cases. Okay, so you can see like this. You can see in different views your results. From here you can see the deflection. Here you can see that the multiple points for which the factor of safety was calculated for each like the for each slices from which point the moments were taken or the forces were calculated. So it is a visualization like for the each slide. And now I will explain why the factor of safety varies in case of Spencer method and Morgenstern Price method. So here we have a class presentation on it. So in case of the method of slices for calculating the factor of safety, there are different methods like ordinary method of slices, Bishop's simplified method, Jambu, Spencer, Morgenstern Price, so etc. In case of Morgenstern Price, we consider a shear and normal interslice forces. We assume a constant interslice force function satisfied both the moment and force equilibrium, the interslice forces, and the both circular and non-circular slip surfaces. So, in case of the other method of slices, you can see that the assumptions are different. Like in case of Spencer method, we are assuming both shear and normal interslice forces, but for some methods, the both of the forces are not like considerable. So uh, because of the assumption, different methods varies. So here you can see that there is no external forces, so Q acting at the midpoint of the slice space when there is no external forces. This is the assumption. So here you can see that there is a pressure from the soil, pressure from the slice, and X is the interslice forces, interslice shear. And here is a angle you can see, that is the alpha. Alpha is the angle with the base. Okay. And gamma is the angle between the force and the base. Okay, so the resultant force and the base. In case of Spencer method, gamma is actually fixed. So in case of this method, gamma is not a variable, gamma is fixed, which is the angle between the resultant force and the base. Okay, so um, now if you see that the calculation methods of Spencer, so here we will pick a trial gamma and lambda, sorry, and compute the force by iteration. And then you can see that we have a force function, and from the iterating on lambda until f is the same for the 2 and 3, these equations, we get these two equations, one for force and one for moment. So from these two equations, you know that we know alpha, we know lambda, we know the C and phi, the properties of the soil, and also uh, we know the weight of the slices. We know alpha actually, but we know that gamma is fixed. Sorry, lambda is fixed, but we don't know the value. So in these two equations, lambda and factor of safety are unknown in both of the equations. So what we do, we just pick a trial value of lambda, and after putting lambda in this equation, we get different values of factor of safety, right? So we will just draw that in a graph like this. Okay, we will pick the trial values of lambda and we get the factor of safety from those equation, and we will just put the factor of safety here. From that, you see we have two equations, one for moment and one for force. So suppose this one is for force and this one is for moment. So these two curves will intersect in a point like this. Okay, so that's the point of our calculated factor of safety. So that's how in Spencer method we calculate the factor of safety. But in case of Morgenstern price, why it is varying from the uh, Spencer method, because all the assumptions are kind of same. The one difference is that in Morgenstern price, lambda is not fixed. Like they think lambda is a variable of different functions like half sine, rectangular, elliptical, I guess. So there is different assumptions for lambda. They don't think that lambda is fixed. This is the one reason Morgenstern price and Spencer method varies. So we can easily run the software and calculate different factor of safety in different methods, but we have to understand that how the methods are working and why each of them are different. Okay, so here are some comparison between Spencer method. Comparison, not comparison actually. There is some weakness and strengths. So the weakness is that you see that at one point these graphs converge, but in some cases maybe they don't converge at a single point. So that's a weakness. And convergence problems emerge when failure surface presents deep sections or jumps. And the assumption made by method is that the inclination of lambda, the resultant force, is constant. So it cannot be used for variable lambda values like variable lambda values are used in Morgenstern price. So you can say that Morgenstern price is a bit more accurate. And in the strengths, you can say that accuracy is higher comparing to simplifier methods. The most simple method is actually ordinary method of slices. I'm not discussing about all of them. And there a small number of slices are adequate to provide an accurate factor of safety and satisfies both the force and moment equilibrium of the failure mass. Also considers it is a good that it considers both vertical and horizontal component of forces and both the force and moment equilibrium. So these are the strengths and weakness of this method, and we have also seen how Spencer method works and how we can run the model to get factor of safety in Spencer method and Morgenstern Price method, and what is the difference in this method. So that's all for today. Thank you.